Okay, so we've moved off the end of the lathe, but seeing as we're talking about lathe setup, let's look at the threads and the feeds. Threading, metric threading, imperial threading or inch threading. I know the word imperial is not a favourite word in the US. You prefer US inches or inches, not imperial, as we know it over here, being still part of the colonies. But we'll just talk about this as far as lathe setups go. Now, what we have here is we have threads per inch, 127 teeth and 120 teeth. Top gear, bottom gear. Right, so we're not saying that we've got to change the bottom gear over. The bottom gear is still running on 127 teeth. It's the top gear we've got to flip over to 120 teeth. So we use 40, 32 or 30, and we use 60 or 66, 65 or 70, depending on what thread we're after. Now, as you can see, we can go from 4 threads per inch to 56 threads per inch. I'm trying to remember what the lead screw is in this. It's metric. This is metric, so it's a metric lead screw. I think it's a 5mm lead screw. I think. I can't tell you off the top of my head. Now, when we're metric, 30 on 127, 60 on 127, or 24 and 60 on 127. And that gives us from 0.4 millimeters per thread to 7 millimeters per thread. Now 7 millimeters per thread is a bit over a quarter of an inch. Quarter of an inch is in rough numbers about 6 millimeters, so we're a bit over a quarter of an inch per thread. So we're in the vicinity of just what are we? We're a bit under 4. Again, we're probably going to end up somewhere around here, around the 4 threads per inch. You know, maybe 3.75 threads per inch, something like that. Without sitting down and working it out. Now, there were a few lathes around that the main numbers that I tend to work with are 1, 1.25, 1.5, 1.75, occasionally a 2. They're the main metric threads that I work with. With the inch threads, 12 and 13, I tend to work with a fair bit. They seem to be common. Occasionally 16 and 18, but yeah, 12 and 13 are the two, because they're the half-inch. It's half-inch UNC and half-inch Whitworth. They're the ones that I normally seem to be working with. I'll bring you over a little bit more so that you can see the feed chart a little bit better. The feed chart again is related to, let's get you back into the right. I haven't done very well here. Okay, the feed chart here again is dependent on what combination we've got. Now I'm on 30/60, so my feed options are limited to this sections D and F of my feed chart. So if at the moment, what are we on? We're on 1F, which you can't see. Let's zoom out and see if you can see 1F. So we're on F, we're on 1. So we're F, we're 1, so our current feed is 0.054 millimeters per revolution. And I'm on, which is out of shot, which is A, so I'm actually not on 054, I'm on 0.109. So 0.1 is about 4 thou, so I'm feeding 4 and a bit thou. There's another one up here. This lathe is set up that I can actually feed both directions just on throwing the lever. let's get this in a shot. This is my A and B, and this is my feed out, feed in. At the moment it's on feed out for some reason. I don't know why I had it set there. I might have been threading out, or it's been a while since I've used it. So that's feed in. This has only got a single speed motor in it. I usually, when I've got the when I put the chuck key in, I usually knock it into neutral so that I can free spin the lathe. I'll put it in the right spot so I can free spin it. That also has the advantage of, if I am slack and I leave the chuck key in the lathe, when I turn the lathe on, it's not in gear. It makes it nice and easy to move. So this lathe gives me from 100 to 2000 RPM. The steps aren't too bad. 100, 155, 240, 360, 560, 850, 1300 and 2000. Yeah, look, it's okay. The advantage of not having a VFD is that my performance on the lathe is constant. The motor makes 3 horsepower, I think it is. 3 horsepower is 3 horsepower. It's 3 horsepower all the time. So from that point of view, it's an advantage. There's a clutch here for engaging and disengaging the feed, so I can disengage, make an adjustment and re-engage without turning the machine off, which is quite good. So I can disengage, get that to move. Sometimes it wants a little bit, everything's out of here. Sometimes it actually likes to, the little bit of oil drag gets things turning and everything meshes better when it's running. So often I'll make my adjustments while it's running. When I say running, I'll disengage it, and a little bit of oil drag just makes things tick over a little bit when it meshes. I haven't found a good coolant that I like. The coolants are great if you use them all the time, but I'm not using it all the time. And so this has been sitting for a little bit now with coolant in it, so I'm going to have to pull it all out, scrape it out, pull the pump apart, clean the pump out, because it'll all be turned to white, cakey crap inside the pump. So finding a coolant that I like at a price that's affordable, realistically affordable, is still proving to be a challenge. I tend to be a little bit of a tightwad when it comes to buying coolants. I want good coolants that I can put in the machine and leave in the machine with no maintenance, and I don't want to pay much money for it. That's me, so I imagine I'm probably not different to a lot of my viewers. So yeah, one other thing here, that's probably why it was sitting at speed B. Do not run this machine at speeds higher than 770 RPM in position 8. This machine will take a pretty big hit, It's not uncommon for me, or cut. It's not uncommon for me to take 6mm off diameter on a single pass. Not fast feed rates, but I'll often go in 6mm, sometimes even a bit more, at a relatively low feed rate. And what that lets me do is that if I've got a hard spot on a surface, I can get underneath it and I can peel it out from below. Often, in my experience, as limited as it may be, is that if you've got a hard surface, don't try machining it. Try getting underneath it and peel it out, because what you'll find is that if you can get in behind it, and so you're behind it so that your hard surface is actually on the is trailing, for want of a better way of putting it, what you can do is you can actually just peel it out more so than cut it out, because what's underneath it is already disturbed, it's breaking, it's peeling out, it seems to break the surface so it doesn't tear up your tooling as much, and you can go in and take it out. I do that quite often with cast iron. If I can get into cast iron, or get under cast iron, or my first cut on cast iron is rarely less than about 3mm off diameter. Often it's 5. I'll try and get in deep, low feed rate, and that way I'll tear it up. Now obviously you need enough material to work with to let you do that, but that's how I work. If I'm working on a piece of hardened steel, if I know it's only case hardened, what I'll do is I will go in to a depth that I know that if I'm not the material, if the job will let me, I'll go in and take a cut that's deep enough that I can get in below the case hardening and basically peel the case hardening out on a slow feed, and a deep cut. And as I said, what it seems to do is the outer material seems to, for want of a better way of putting it, sort of fracture and break away without tearing up your tooling. That's just my observations for what it's worth, and no doubt there's many people out there with a lot more experience at it than what I have. So we've talked about the lathe setup as far as why we do it. We've talked a little bit about this end. We've talked about setting up the headstock. There's one more little bit that we'll talk about, and that will be setting up, and on this lathe we'll talk about setting up the threading indicator. So what we'll talk about now, this is me just flipping the camera around so that I can't see what I'm pointing at, is we'll talk about the threading indicator on this lathe. Now on the side here you might just be able to see the lead screw. It's actually a 4mm lead screw, it says so here. Lead screw pitch 4mm. Metric thread dial. Up here we've got numbers all over the house. We've got 2, 3 and 4 on one, we've got 2 and 4 there, we've got 3 here, we've got 3 over there, 4 there, 4 there. So basically 3s are thirds, 4s. What's conspicuous on this dial, for those of you who are used to imperial machines in inches, there's no number 1. Those of you who are used to working in inches will be really unhappy when you start using metric all the time. Actually, what I'm going to do is I'm going to turn you off. I'm going to move to give you a better view. Now, I can't see well enough in the viewfinder, so I'm hoping that you guys will be able to see well enough in the viewfinder. When you are working with imperial threads, I always like how you guys go, yeah, I can start on 1 or 4, or I can start on 2 or 3, or I can start on any number. Us guys that work in metric are envious of you, because when we are metric threading, we have our thread pitch and we have a tooth count. So at 0.4 I need 20 teeth, at 0.45 I need 27 teeth, and I need to be working 0.4, 20 teeth, position 4, 0.45, 27 teeth, position 3, 0.5, 20 teeth, position 4. So this is like a honeymooner's 90 when you're doing threading. It's on and off, on and off, and the gears, well, you're changing gears all the time. You could have a 27, a 21, a 26, a 20, there's a 22. It's just not as pleasant an experience as what it is threading in inches. What makes this worse is that because it's a 4mm lead screw, there's not an easy conversion for putting a gear on the bottom of this and getting a nice easy getting a nice easy inch usage up the top here. So there is an inch indicator available for this lathe. It is available an inch lead screw, but what it means is I've got to change the lathe to inches. Inch lead screw, I've got to change the lead screw out, I've got to change this out, and quite frankly it's probably not that big a deal, but it's just a pain to do it every time you want to run a thread. So with inch threading, what I'm doing is when I'm threading inches, I set this up. Oh, I say set this up. When I'm threading inches, this is my half nut control. basically I lock the half nut and I use my foot brake on the lathe. I back it out, I then run it in reverse, come back, stop it, run it forward, or back to my 0 point, make my adjustment, run it forward, and away I'll go. Same as what you guys on inch machines do when you're threading metric, or those of you who haven't got dials do. You just got to keep it consistent. It's got to stay locked in. The other thing that I notice on this machine is that the clutches tend to be, the overrun clutches tend to be a bit sensitive. I haven't worked out how the one works on this on the lead screw yet, and that's a bit of a problem, because what it means is that when I'm running backwards or I'm threading in reverse, I actually need to apply a bit of, for want of a better word, safety pressure to the handle as it's going backwards, because it takes very little load on this to make the safety clutch overrun when it's going in the reverse direction. So I need to sort of use the thread as the lead screw as an assistance device. It's more of a control than it is a primary driver. When it's running up to the headstock, it seems to be quite okay. Within reason, you know, it's a safety device, and when you overload a safety device, it does exactly what it's meant to do. It kicks in. So from that point of view, it's not too bad. But I just need to be, once I'm aware of it, it's like every machine, it's got its idiosyncrasies, and once you're aware of them, it's not too bad. But until you become aware of them, it will bite you in the bum. So that'll probably conclude today's video. It's probably turned into a video series now. It's more theoretical. It was more theoretical than it was practical. It's a bit of a tour around the lathe, but that's why we set the lathe up. Why we set it up so that it doesn't bend. Why we set it up so it doesn't twist. If you're machining wood in it, who cares? Plus or minus a few thousand either here nor there. If you're precision machining, plus or minus a few fraction of a thou, or a few hundredths of a millimetre, or a hundredth of a millimetre, can be significant in what you're trying to achieve as an end result. So yeah, with a bit of luck, in the next couple of days I'll actually spend some time back in here and do some more work on it, with it, get on it, do some more time with it. And thanks for watching. Please subscribe, please make comments, and hopefully I'll be doing quite a few more videos soon. But I know that for the next probably 3 weeks I'm running around the countryside, so hopefully I can put up a few videos just made out of bits and pieces. Thanks for watching.